Hello friends, welcome back to the channel. In this video we will solve one problem related to the engineering mechanics, right? So we will use the concept of Lamis theorem to find the equivalent of the forces. So what it says that we will see in a while, right? Let's first read the problem statement. The figure shows the two equal forces at right angles acting at a point. So let's say two forces P and P which are at a right angle acting at a point. So these two forces are acting on this point. The value of the force R acting along their bisector. So value of this point force R which is acting along their bisector of these two force P. So these two forces are at a 90 degree, so bisector will be at 45 degree. If we extend this two, so that will also bisect the third quadrant. So this angle would be 45. And again this angle is 90, right? So total angle would be 135. I hope you got the concept. Similar way, this angle would also be 135. This angle would be 90. So we have to find the magnitude of the force R in terms of these two forces P and P, right? So we will use the Lamis theorem. Lamis theorem, what Lamis theorem states, when three forces, 1, 2, 3, when three forces acting at a point are in equilibrium. So these three forces are acting on this point are in equilibrium, then each force is proportional to the sine of the angle. Each force is proportional to the sine of the angle between the other two forces. So each force is, in case of R is proportional to the sine of the angle between these two forces. Similar way, P is proportional to the sine of the angle of these two forces, right? So in general, let's say there are three forces, P, Q, R, having the angle alpha, beta and gamma. So according to the Lamis theorem, P, magnitude of the force P, and angle between the other two forces R and Q, sine of the angle between the other two forces, P upon sine alpha is equals to Q upon angle between the other two forces is beta, sine beta is equals to R upon sine gamma. So this is what the Lamis theorem states. Whenever three forces are acting on the point are in equilibrium, right? So same thing would be happen over here. Now try to solve it by yourself, and whenever you are ready you can continue with this video, right? So let's solve this for our system using Lamis theorem. Now if we consider this force, so P upon sine of the other two forces, angle between the sine of the other two forces. So angle between these two forces is 45 plus 90, sine P upon sine 135 is equals to this P upon, again this is sine 135, P upon sine 135 degree is equals to R upon this angle would be 90, sine 90. So we have to find the equivalent force R in terms of P, right? So let's make this term as a left hand side. So R upon sine 90 is 1 is equals to, we can compare it with any one of these two terms. So P upon sine 135 is equals to P upon sine 90 plus 45. So we know the property of trigonometric function sine, that is the odd function. So P upon sine 90 plus 45, since it is a 90 plus, that means the trigonometric function sine is converted into cos and 45, and since it is in the second quadrant, 90 plus 45, it is in second quadrant, sine function is positive in the second quadrant. So P upon cos 45, but we know that what is the value of cos 45? P upon cos 45 is nothing but 1 upon root 2. So denominator would be numerator. So root 2 times P. This would be the solution. Right? I hope you understand the concept. If you do so, do like, share and subscribe to my channel for such a more content, and hit the bell icon for latest notification. We'll see you in the next video. Till then, goodbye.